All right, welcome back. We are COMP1115. That's Game Programming 1 in the fall 2025 semester at Georgian, and it's week 12, part 1 of our broadcast and recording together. And just wanted to go over where we are this week. So last week, we talked about simple input-output, saving and loading with our stream reader and stream writer. The other way around, stream writer and stream reader. And we also talked about exception handling. So we talked about try catch and those kind of things. I think that was for some of you new, actually for most of you new, I would say. That was something we talked about last week. And then we also used standard forms for opening and saving files. So we used the open file dialog and save file dialog. That's what we did. And this week we're going to continue with that. And what we're going to do is we're going to have, we're going to talk about structs, which are a custom data type. And this is kind of our intro into object-oriented programming starting this week, kind of, because once we start talking about structs and we start talking about custom data types, we start thinking about how can we extend them? How can we make them more powerful? And this is where, I would say, object-oriented programming in classes came from. The idea of a container that contains more than one property. So we're going to talk about that. Data persistence. We're going to talk about binary saving and loading, as well as storing structs as JSON data. So we're going to talk about what that is, JSON. And we're also going to be talking about Windows Forms controls, a new one called the menu strip. So you're going to make a little menu to help us out to select which file to save, which file type. So that's what we're going to do today. Lots of stuff to do, as always. It's due tonight at midnight. We are recording the session, and here we go. So before we begin, I want to start off with our project copy and all that stuff that we're going to do. So I've got a project that I'm going to use. So last week we had ICE 10. I've completed mine, and I'm going to use this one. I'm going to copy paste. And I'm just going to convert this into ICE 11. Actually, I'm not going to do that. What am I doing? Ha ha ha. See, I was going to do the rename thing. Let's try that again. I'm going to make a brand new project. That's what I'm going to do. Create a new project. And then that new project is going to be called ICE 11. So there you go, Forms app, right? And we're going to go call this ICE 11. There we go. And create that project. There we go. And again, all we care about is that we have a project structure. Okay, so we care about once this thing launches, we're going to close it down. And we're going to close it down because we're going to delete everything pretty much, just the structure. I just want the dependencies and all the stuff that's in the background working for us to make things go. And then we'll copy paste everything that we need. So there we go. So we've closed everything down. We've made ICE 11. I'm closing all of it down. And then I'm going to launch 2 Windows forms. That's kind of the way we did it last time too. So there's the first one, Windows Explorer, Windows, in the operating system. We're going to do this. There we go. So this on the left side, we're going to have, our old one. On the right side, we're going to have our new one. And we're going to copy stuff from our old one to our new one. Now, one thing that we have to do, I'm just going to go into this one for a second. Definitely copy in your Git attributes and Git ignore. Some people forget to do this. And then they're like, hey, I don't know why, but I can't, do GitHub from my Visual Studio. Remember that Visual Studio will prevent you from doing anything with Git or GitHub unless you have your Git attributes and Git ignore files. You need to have those things in there. Git attributes is not really that important compared to Git ignore. We need that one, copy and paste into our project. First thing. Then, so go back out to the one that I want to use. Then what I want to do is I want to copy in the forms that I want to put into this one. But before I do that, I want to get rid of the old forms and the program file. So get rid of all those things from our brand new project, and then copy in the stuff that I want from my older project. So I'm just going to get all those. Make sure you get the designer, but not the other stuff that we don't need. There's certain things we won't need. You can see that there is quite a few there are quite a few things now because our project has grown to a larger size. So copy those, put them in. So that's the next part. So I've just copied our forms and everything else into our new project. I can close down our old project now, and I can go back out and double click on my solution file, and we should launch our project. Now, a couple of things about this one. We know that is a lot of stuff, right? We know that we need to rename because our project is called ICE11, and our older stuff, that's called, for me, it's called ICE10 completed. I'm going to rename those things. For you, it's going to be called ICE10, right? So I'm just going to double click on one of them. So here's my project, my program file. And what I want to do is I want to rename this. So I'm going to press Control H, and notice it brought up what I was renaming to ICE11. So anything that has my name of my old namespace and the name of the new namespace I want to put up here. And then what I want to do is I want to press this button right here. I'm going to circle it because people had trouble with this last week for some, I've heard. So this button right, these two buttons right here, the first one, this does one, and this one does all of them, right? So that's what this does. So I want to do all of them at the top there. So that's what I want to do. And I want to press this button. And when I do that, it's going to say, okay, you've replaced 17 occurrences, and press OK. In my case, it's 17 occurrences. For you, it might be another number, but it should be like that. So now everything is ICE11, right? And what we should do is test our application at this point to make sure that it's working the exact same way that the last one did, with all the bells and whistles and things that we expect. So I'm just going to close down this tab so there's nothing open, and press play. And we should have ICE11 working tickety-boo. All right, so there's our character generator form. We have this. Let's test it completely. So I'm going to load a character. Again, we have our data that we have. Our saves. There it is. And in my saves, I have a couple of characters, test characters. I'm going to go with this one, character.chr. Open that up, and you're going to see that I have my character that I'm testing with. There it is. Right, and if I click next, I have an empty next form. We're going to work on this next week. Then click next, and we have it over here. And what about if I want to save it as something else? I can save it. It's going to come up as the name of the form. That's what you had to do last week as part of your in-class exercise 10. And I'm going to put this into my saves folder as Conan. There we go. It saved, and everything worked okay. The other thing that I want to check this out, is I also want to check to see if I can just load something instead of making a new one. So I want to make a new one instead of just loading. So new one, I want to call this, Brackus the Bad, right? And I'm going to choose another career like Scion, and I'm going to make it a robot psionic dude. I don't know how that's possible, whatever. And then click next. And then it's going to go here, and you can see I've got robot, and I'm going to save this guy as something else, right, in the saves folder. There we go, save. And now that's saved. We should check it out. We'll stop this one, and we should check it out to make sure that it all works. And I'm doing all this to verify. So I'm doing the verification. It's super important because we cannot assume that things are going to work until we open them up and check them out. Okay, so that looks like it's pretty good. Okay, so that is, kind of our program working exactly as we expected it to do. And this is where we put it up on GitHub because we're ready to go. So like normal, I'm going to go into my PowerShell. That's down here. You can also go to View Terminal, and I'm just going to do git init, git add dot, git commit -m, initial commit. There we go. All that's done. And then I'm going to make a new repository on GitHub right up here. So let's do that. So here's my old one, make a new one. And we're going to call this COMP1115 in the fall 2025 semester, ICE11. There we are. Going to make it public for you guys so you can see it and you can follow along if I'm going too fast. And then create repository. It's going to give me some steering instructions. That's what I call them. They're just a few lines of code that I'm going to put into Visual Studio. So I'm just going to copy this, go back into Visual Studio, right click and paste, and press enter. And when you do that, It'll push everything up to GitHub. If you've configured everything properly, if I refresh, we're good to go. Now, I went at a good pace, and this is how fast approximately you should be going at this point, because we've done this all semester for the most part. And, if you're not, if you're going a lot slower than this, you need to practice, because in a couple short weeks, let me just come up to pull this up again. If I go back to our schedule, next week we're doing OOP, right? And we're going to upgrade our struct to a class. That's what we're doing. And then the following week, that's on the week of December 8th. So the last, I think our day is the 12th for our exam. Let me just pull that up so we can see what that looks like. Here's November, here's December. So that week is the 12th. So again, 2 short weeks from now, on the 12th of December, that is our final exam. It'll be in person only, barring any crazy weather. If we have more weather like this, then I'll rearrange it so it's online. But, because again, I prefer to be in person, but today it just conspired against me. I just saw the weather coming, and I was like, 8 inches of snow, whatever Barrie has right now, is pretty crazy. So, I wasn't going to drive. I wasn't going to make you guys drive for 8 a.m. For some of you to be there. And it could be pretty treacherous along the 400 or wherever else you're going. So that's why, kind of decided not to do that today. But let's continue with what's happening now. So we're kind of sitting here, and that's why, like I said, you have to know how to put your project together at this point. I think it's pretty reasonable that you know what you're doing. On that though, let's talk about the new topic of the day called structs. So what are they and why do we need them? We've been adding new things the entire time, and next semester, what you're going to get is a lot of reuse. So some stuff is going to be new next semester. Wallace is going to take you through and review object-oriented programming again. I'm going to cover it just in brief, with 1 week next week, but just as an intro. One more thing I should say is, in terms of the stuff, what is your final test going to be about? We will use, just letting you know, we will use this project that we've been working on for the second half of semester, right, which is our Windows Forms application, as the test, right? And everything that will be included is anything from week 8 to week 13. So that's, you have to kind of know how to do all those things that we've talked about, and as well as using any of the structures and things that we've said. It could include other things that I've asked you to do, but as we're going forward, we're going to do more and more. So hopefully, you'll be able to be clear on one of the things that you need to do. Let's go on with what we're doing. So structs, yes, let's go back to that. So what is a struct? Struct, in my words, is like a container object. It kind of creates, a custom type. So we have types, right? We have integers, we have doubles, we have Booleans, we have strings. We've been working a lot with strings this semester. There's all kinds of different types, floats, and so on. Those are built-in types, right? Types that have been defined in C#, right? Those are the types. Some of them are primitive types, so we can talk about integers and floats and doubles and bools. Those are all primitive types because they're very simple. They have, we know how to access them and so on, and they only have one way of, kind of assigning data to them. And then there is more of a complex type, which is the string, right? So string is a complex type. And then we have other structures like arrays, like we've talked about, and lists. A list is a collection of data, more complex. And what a struct can do is it can put any of those built-in types and built-in structures together into one container that has a common name. So it's like an enum, where enums kind of list off certain things, but they represent, the underlying numbers are like 0, 1, 2, 3. That's what an enum does, right? A struct is actually building something new. Okay, that's kind of the first part where we're making a custom type. This is really great because it allows us to put a bunch of fields or properties, or some people call them data members, inside of one structure. So this is the one how it would look. So again, struct contains fields that store data, and each field uses standard C# data type. Okay, so kind of like this. So this is kind of an idea of our struct. Now we want to make this struct because this is part of our in-class exercise 11. So I'm going to copy this part. And I'm also going to populate that in your chat so you can follow along. There he is. So this is the struct. I'm going to take this and put it into my program.cs file, program.cs. So inside there, you can see that we have above the class program, we have two enums, right? So form type and toast type. We made toasts last week too. I know that was a big joke for some of you, but it was fun to make. And now we're going to add in this new type, which is called character data. So struct is very basic. It's a very, very basic type. Notice that we have the public keyword in front of the data type. We're going to talk about access modifiers, which is what this is, an access modifier. Next week when we talk about object-oriented programming. Object-oriented programming is going to be a boot camp on how to use, classes. So it won't be all the details. You're going to get all the details next semester with Wallace, but you'll understand at least next week the difference between public, private, and protected. We'll talk about those things. There's 3 common access modifiers that are there, and so on. We'll also know the difference between a static function, or static class, and a class that needs to be instantiated. We'll talk about that instantiate word a little more. Structs, though, for now, I want you to think about just putting the public keyword in front of the data type. So think about it this way. We're grouping variables together. That's what we're doing here under one name, character data, right? So character data, and we can still assign data to them and read data from them. We've seen this kind of structure before. It's not completely new because we're kind of doing that with our settings, right? Aren't we? So here's our settings. And in settings, we have all these things, right? Kind of where we're storing data as well. They're all strings and so on, right? And in our settings, what we have, if you think about it, is the way we've been loading and saving. We're using settings.default dot, and dot is the dot accessor, right, that we're going to talk about. It's the dot operator, actually, is what we're doing. So we're going to do the same thing with our character data. So that's what we're going to do. So the way you declare a struct is you use it like a type, just like as if it was a string or an integer. You just say whatever the name of the struct you make this custom name yourself, and then you assign a variable to it. So character data, lowercase, like this, is of type character data, which means it's like it contains all this stuff. Okay. One thing that you need to know, right, that before you access a field, a data member that's in here, you need to assign data to it, right? Otherwise, it's empty, right? It's just letting you know. It doesn't include anything that's in here at all. So again, we're going to be using the dot operator, right? And I know it looks like a decimal point or whatever, but the dot operator separates, it talks about going deeper into a particular structure. So again, if I go back to this idea, up one, so we can see that this is the struct name, character data. And if I want to access the agility of the character, I would say character data, the lowercase, this variable name, dot AGL, where the AGL is the agility of the character. And so the dot operator, we're going to see this more and more, especially next week when we talk about classes, right? Where we want to use the dot operator to access data members. That's members of the class or struct, in this case, our struct, or methods that are part of the class. And we've seen that too. We've been doing it all semester, really. The second half of semester, because when we look at our program, and if I access our program is a class, if you think about it, and it has similar things to a struct where it has a bunch of data members. That's what we have here, right? So you position them differently. That's fine. But, so then we're going to, if we take a look at our other form, let's say, for example, I want to look at selection form, right? And when we look at selection form, and if I kind of pull that up for a second, if I do if I go to look at the code view, again, code view, you can use F7, or you can right click here and go to code view, view code, right? Then you can see that here we are. You can see that this is what we have. And if I want to access something that exists in the program because it's in the same namespace, then we can simply just say something like program dot. Here's an example of the dot operator where I use the name of the program followed by dot. Dot is a dot operator that allows to access properties and methods, right? Methods being functions. Okay, so that's what we access. We use the dot operator for a bunch of stuff. You see it everywhere. Button next dot enabled. Button next, it's a class, an object of type button. It's just called button next. The dot operator accesses the property, which is the enabled property. And we see that everywhere. Convert dot to int32, dot to string, where we're converting something to a string, and so on. There's lots and lots of things here that we've done with the dot operator, string dot empty. We've kind of done that many times. But I'm telling you that that's what it is. It's a separator, and it allows us to dig deeper into that container that we're looking at, whether it's a class or a struct or even a namespace, right? So remember, we can access the namespace the same way. System.diagnostics dot, and then that's a namespace, right? Okay, so back to this. So we're talking about the dot operator. And again, if I want to assign data to a struct, we would do something like this. So let's suppose I have the stream reader from last week that we talked about. And instead of kind of populating directly into settings, I could do something like this. I could say character data.agl for agility is equal to the reader.readline. So I can read directly from the file into my struct, which is pretty cool, right? So same idea, it looks like settings. I can also go from the struct to something else. So here's an example of where I take my data from this struct, and then I populate it into settings like this. Okay, so this is something that we can do as well. So again, reading from a struct, all we need to do is use the struct name followed by the dot operator, and then the member name. Okay, that's how we do it. Okay, and then we kind of save everything over. So I think it's pretty good in terms of how we do all that stuff. I think it's not that difficult to do and understand because we've been doing it the entire time. Not something that we've been doing. It's just a matter of understanding. Now we're doing it for a struct, our own custom data type. All right. So what we want to do is I want to update the load character, and I want to use our struct that we have right now, and instead of something else. So let me just go and do that with you right now. So I'm going to do it by hand this time. So back to program.cs. I'm just going to close these off just to have one. We can look at the existing load character. Here's our load character. And right now we use these temporary variables right here where we load all this into here temporarily, okay? So we want to replace this with our struct data, but we have to instantiate an object of type character data. We've declared it here. Here's where we declare, way up the top here, our struct. So this is what we're doing here is we declare a struct that holds the character data. That's very nice. There we go. And then what we want to do is we want to initialize the struct. And the way we would do that is inside of load character, because that's where we need it. We're going to do it somewhere before probably even stream reader. So stream reader, remember last week what we used it for? It's a method for us to read data from a file. So here we're just going to say character data, and we can call this character data lowercase like this, right? Now you could use the new operator, so you could do something like new character data. That is totally fine if you wanted to do that. Structs are a little simpler though. This is what we're going to have to do next week for classes when we make something like a struct, right? But instead, all you need to do is this. That's all that's required. You just have to kind of, this is the way we kind of, this is not declaration. Let's go back up there. This is, create a struct to hold character data. That's what we're creating. We're kind of you know, kind of clear, almost like a little blueprint, if you will, right? So we're not actually using it here. This is not anything right now. This is like saying, here is our custom data type, right? Which is, that's what it is, right? So custom data type, that's what it is. To hold character data, that's what it is, our own custom data type. So here, down in here where we were before, we're declaring it. So here we declare a character data struct to hold the loaded data. That's fine, I like that. And then what I want to do is I want to use it instead of this, right? So that means that instead of var this would look like this, character data dot, right? We're going to fix the errors in a second. So all I want you to do is just replace the var and a space with character data dot. And if you just do that and do a replace, if I can do it properly, kind of like that. Yes, there are quicker ways of doing this, but I'm going to go slow because see how they all highlight when I do this? I can do them all at once, but I'm not going to do that right now. So I'm just going to go one at a time. And you can see that when I do that, right, then what happens is I replace the stuff that I already have with this. Now, there are some side effects, right? For example, AGL by itself doesn't exist. You have to put character data.agl. So let's do that. So that means this little if statement here is going to need me to do the exact same thing. I'm going to fix these up in a second to make them more usable because they're really long, right? And like that. There we go. So that's all. Remember that spaces don't matter in C#. You can space things out as much as you want. So I'm going to kind of put two things on a line. And what I can do here is I can kind of press enter, and I can avoid what Visual Studio wants me to do. I can align things the way I want, and I can do this to make it look a little nicer. It doesn't matter how many lines it takes, you know, as an example. I'm just going to do this so that way it feels a little easier for me to read, right? And it doesn't take up a whole bunch of spaces, right? So there you are. So this is the thing that I've done. I've made an if statement. If any of these are null, that means that we've got data that's empty somehow from our file, and this would cause a file format exception. We talked about exceptions last week, right? So that's what it's done. And the same thing goes with the other ones. Whenever we read stuff, it'd be the same. I just talked about that. So I'm going to kind of grab that dot operator, and I'm just going to do the same thing like so. Just populate that in. I could certainly type that, but why if I can just copy paste? There we go. So that is a drop-in replacement for what we had before. We're using, instead of using a temporary variable, a set of variables that we defined here, we're just using our character data instead. Okay, that's what we're doing here. Everything else remains the same, and if you check it with what I've done here, it's exactly the same that's in the PowerPoint for the most part. That's all I've done, right? So now that we have this, let us run it because we've made a change, and let us you know, check it to make sure that it works. So run. So I haven't added any more functionality to this thing. I'm just using a struct instead of variables, right? So again, this is in load character. So I'm going to try it out. Load character. I'm going to load my character I just made today, this guy, right? And press open. And if I do everything properly, it works great. That means that indeed my struct is working. Questions around structs, because that's what they are. They're a custom data type, ability for us to use to produce something that is our own data type that we want to use. That's what we're doing, right? For here, any questions around that? Thoughts? When I first learned structs, way back in the day, you know, as an example, way back, I was super excited about them. And the reason why is because in my mind, it opened up a bunch of possibilities. Once I figured out that I can use structs and that I can make my own custom data types, here's what I also figured out. I can make structs that include other structs. Yeah, right? I can make structs. I can make a much more complex thing that I can come up with using structs. That's what it allows me to do. My mind was like mind blown. Wow, I can do a lot now. With that, because now I can group things together. If it's my own custom data type, I can make a list of structs. I can make a list of my own data type. I can make a list of, character data, as an example, where I can have more than one character being saved at the same time, or whatever I want. Really, really cool that way. And there's lots of great examples out there that we can use too. For example, if I want to make my own, and I'm just doing this for practice, not because I want to do anything else. Let's, first of all, we've done this already. Let's put this up on GitHub, because we just did something. So we'll say git add dot git commit -m, and we'll say we converted, right? Or I will say we implemented. How about that? Implemented the character data struct and program.cs. That's what we did. Hit push. So that's our first push beyond the regular one. And if you think about what we did, we made this, but we can also do something else. We can make as many structs as we want. There's no limit to the creativity that you can have. And so here, what about if I made a public struct and I wanted to call this a vector2, right? Here's a vector2 struct, and it's giving me some suggestions, but I want to ignore it. I want to have two things in my vector2 struct. I want a public integer. Let's suppose I'm doing integer x and y positions in the screen, int x, right, for the x position, and a public int y, right? So those x and y. Now, what it likes to do, notice that it doesn't like the fact that I'm using lowercase. For structs, they like uppercase, like this, right? That's what they want from how to start off a name. You don't have to listen to this, as an example. I personally think that it's perfectly fine to do this, and you can ignore what it's telling you in terms of the style. So here's a vector2. I'm holding this information here, right? And a struct as a vector2. I mean, let's just show you what that looks like if I was going to use it. You've used vectors in Unity as an example. So here I'm just going to just show you what that might look like if I went to the main function. So if I was going to go to, let's just come up here to the main function, and this is what it might look like. It might do something like this. It might say something like, vector2, and we'll call this, like a point maybe in space somewhere, like, center, right? And that's going to equal to a new vector2 object, right? There we go. I could do that, or I can simply just say vector2 center. Then I can say something like center.x is equal to 5, and center.y is also equal to 5. There we go. I can do that just like you're using a a vector in Unity. Now there are some things that we can do that is different with structs, because structs can also hold methods. Okay, it can be done, and structs can also have a constructor function, but that's the topic of another day. So in other words, this little vector2, I'm just going to preview this for you, could have another thing called vector2 in here. Remember, vector2, the name of the constructor function. That's what it would be like. And again, what we want to do is make it public. There we go, public constructor called vector2, right? Just like we have a constructor function for program. We can have a constructor function for program, and it's the same name as the name of the class, right? And how do we know this? Because we've seen it before. If I go to selection form as an example, and if I pull up that the code, we can see that selection form, right? The class name is called selection form, and we have a selection form constructor. We talked about this last time. The one that's really telling for us, really, when we talked about this last time also, is the toast form we made last week, right? So toast form looks like this, right, approximately. But toast form has two constructors, right? We have a empty constructor. That's what this was, empty constructor. We talked about that last week, right? And this one was a parameterized constructor. That's what we talked about last week as well. a constructor that takes parameters. And all the constructor is, it's just a fancy word, but in your mind, what you should think about when we talk about constructors is it's a function that runs, that is executed at the time that we make our new data type. That's what it's going to be. As soon as we make it, it runs, right? And as soon as we execute the code, that's the first thing that runs. It's like in Unity, the start function. The start function in Unity is the thing that's going to run as soon as you access any one of those monobehavior scripts. Okay, it's the same idea here. And it only runs once. That's also something to know, right? So we're going to talk about that in more detail next week. It's just a preview. So if I was to do this, I can have an empty constructor. And if you don't put anything in, I could assign details like this. I could say something like, well, X is equal to 0, and so is Y. Y is equal to 0. So if you enter an empty constructor, as an example, then this is going to be, it's just going to give me X and Y for the vector. So I can actually make a new vector2 object with nothing, and it'll give me X and Y 0. I can also make a second constructor. So I can overload this constructor with parameters. I can say it takes X and Y. Oops. It takes int X and int Y. Could do that, right? And just like we did before, I could say something like X is equal to, now I got to use the keyword this for this one, and I'll talk about that next week as well. And this dot Y is equal to Y. We'll talk about the difference. And it basically says there's a problem. It says methods must have a return type, right? So even though I'm using this vector2, there we go, it's the same thing. So one is parameterized here, right? This is the the empty constructor, and you can have other ones too if you really want to, right? Ones that take different kinds of data. So here's an example of a vector2. When we're using we can make a struct of our own that kind of looks like this. I'm making this for you to make you understand that you have control over the type of data that you create. Like when you're making a custom container like this, then you're making something that looks like this. And then if I go back and I try and use it again, I can do it differently. I can say something like vector2, we'll call this, center point, right, is equal to a new vector2. I can now use the constructor function where I can pass in new vector2, where I can pass in the data. So I can say like 10 and 15, or 10 and 10, sure, that's fine. And then I can do something with it. As an example, I can add two things together. There's lots of things to learn about using custom data types. For now, though, this is not what we want to do. I just want to show you that it can be done, just so that you know that there's more to this, that we're just scratching the surface of what we can do with structs, that there's much more you can do with them. For now, all I want you to think about them, I'm going to erase this, is that they are data containers. That's all they are. They're something that hold a little bit of data, and there's something that we put together. I would rather, with what I just did, I'd rather use a class. Classes are more powerful in many ways. They have a lot more options than structs do. And there is a difference between a struct and a class that we'll discuss next week. But I want to tell you that this custom data type that we've created is the first step into a much larger world, right? In terms of what you can do when you program. Okay, so I want to talk about that with you. So a little step into a positive direction. All right, so now that we've done this, we've kind of created our data, and we've done this part. I want to move on. We're going to take a short break soon, but I want to move on to data persistence in a different way. So last week, what we did was we talked about stream reader and stream writer, right? Stream writer and stream reader. We created streams. So that gives us text data like this, right? So example, I can open it up and I can look at it, right? A lot of times when we make applications, we want to access data, and that data, we don't want it to be looked at for some reason. We want to make it a little bit more difficult to look at, right? Or we want to make it faster access. Static void main. There's nothing here anymore. I've just deleted it, Damien. I was just using it as an example. Um, so so again, I was saying that what we have is data that we can see. It's called clear text. Clear text is interesting because it gives us the ability for us to to kind of test what we put in there, and that's fine. But what about if we want to save password information or credit card information or something else? We don't want to use clear text. Okay, we want to make it so it's more difficult to be used. We can use binary for that. Now, we also probably want to encrypt that data, but that's a whole other process we're not talking about right now. Again, a larger world we're stepping into, right? But let's say something else. Let's suppose that I don't just want to write data, a small amount of data, like one character, but I want to write and read multiple characters or many things at the same time. Reading from a text file is quite slow, right? And when we need speed, we use binary. Binary is a series of bytes that we kind of save, and we have sorry about that. We have two structures that we kind of previewed last week. We kind of talked about them very briefly. Binary writer and binary reader. So what binary writer does is kind of similar to what we did with stream writer, right? Instead of writing text, it writes file in binary form instead of it, right? And what this means is data stored in bytes, which is very, very small. It's not human readable, right? And what it does is it's very compact. So it kind of, there's no spaces involved or anything else like that. And it's super fast to read, and it's ideal for saving structured data, right? Such as numbers and strings and all kinds of other stuff. That's what it's for, right? So that is binary writer. Binary reader, one thing that has to happen with binary is the way you write it is the way you read it in. Okay, so there is no option to read from different lines or something like that. In fact, one thing that you're going to note is that binary writer does not have a write line. Okay, it does not include a write line like stream writer. Stream writer allows you to write different lines with a new line character. That's what it does. So you can also do stream write, stream writer.write, but binary writer does not include that. It only includes write, right? And what it does is it writes data in contiguous memory locations on in your file, one step at a time, almost like next to each other, just like you would write an array. All right, so that's how it kind of writes the data. And in many ways, it writes the data that we like how we store data in memory, in random access memory, RAM. Okay, like we're talking about. So one thing that we're doing is when we write stuff, okay, a couple things to note is there's two parts to this now. Okay, so it's a little bit more complex than what we did with our stream writer. Okay, stream writer, we didn't really need a file stream. I talked about last week, the file stream, if you recall, is a lower level, kind of construct that we don't really need to use last week. This week, though, we need to kind of create a reference to the file because binary writer treats things differently. It needs something like file data with more detail than we would provide to stream writer. It's not just enough to give it a path. It needs some more information. Okay. So here what we're using is two things. We're using file stream, right? We're creating a file stream first, which uses the path that we're going to get into my save character binary function, right? And here what we're going to do is we're going to use this file mode open or create. So what happens is when we save, we kind of configure the way we're opening up our file here, right? Because we're opening up a file to save or load, right? Here we're just saving it. So what we're doing is we're saying, hey, this file stream we're making, we want to use only for opening or creating files. That's what we're doing. The reason why we're saying open or create is because if it already exists, we want to override, right? Overwrite the thing. Okay. So we create a binary writer. That's the next thing we do, similar to what we did with stream writer. And we're just giving it the name writer. as the variable name. That's the reference to this object. We're using the new keyword to instantiate an object of type binary writer, and we're passing in to the constructor function the file stream that we've got from the other one, right? So here we make the file stream, then we pass a reference to it inside of our binary writer. Once we've done that, then we can just use it as normal. Writer.write, and we can pass in stuff. Now notice that there's another thing we're doing here. We're doing this. We're doing this. And that's new. So we have to talk about it a little bit before we actually I'm going to give you this thing in a second. But I want to talk about what this double question mark is. This is a new construct again in C#. So what is it? So the double question mark, this operator is called the null coalescing operator. Kind of a new thing in C#. New as in like, over the last 10 years, new. C#'s been around for a while. And what it's used is it provides a backup value, right? Just in case an object is null. Okay, so why do we need it then for here? We know that they're going to get something we know that we're going to get something from settings where we store our data, agility, strength, vigor, and so on, right? But guess what? The binary writer doesn't know. The binary writer is a nervous object. It needs to know that there's nothing null, because if there's anything null, it'll crash. It'll create a problem when it comes to writing, right? So anytime I'm writing, we need to basically use this null coalescing operator that basically says this: if this is good, take it, whatever the data that you're getting from it. However, if it's not good, enter in an empty string. So it's going to give us an empty, like something that represents a byte that represents nothing, right? As an example, because it, basically we can also do it another way. We can say we can test to see. There's another way we could do this, and instead of doing it in one line like this, we could test. We could say if our settings default agility is not null, then make it, assign it here. Otherwise, if it is null, assign the empty quotes. We can do that. That's like 3 lines of code, right? Or actually, that's 5 lines of code or more, right? Because we have to do an if else, right? We could also use the ternary operator. We can say something like writer.write, and then we can say, depending on if settings.default.agility is equal to null, then you would, we would say, use that one, or, colon, we could use something else. We can use the ternary operator here too. There's many ways of doing it. C# has provided a construct where we don't need to do all those things. The double quotation or question mark here, double question mark, which is the null coalescing operator, allows us to do that check. So example, here's another one. Let's suppose I want to assign a value to score, right? And I have a save score. Well, if save score is null, then we would be assigning null to score, and that would be very bad because it needs an integer. It doesn't need it. That's the only thing it can take. So this would cause a problem. Well, we can do is this. We can say, hey, if save score is okay, then assign it to the score. Or however, if it's not okay, assign 0. That's what this is. If it's not okay, assign 0. If this is null, assign 0. So that's how you read. You can also read it like this. If save score is not null, then you use it, right? If save score is null, then 0 is used instead. Okay? In this scenario. So that's kind of what we're saying here. If settings default agility is not null, then use it. If it is null, then use the empty quotes. Okay? So we need to do this for a binary writer because it's a nervous object. It's going to break if you try doing it any other way. And I'll prove that to you. Let's try this out. I'm going to put this new way of writing into our program.cs. So I'm going to give you this, kind of code like this. Here it is, right? And I've just given to you in the chat. I'm going to take this same thing and go into my program file here, program.cs. I'm going to scroll all the way down to the bottom. That's where I want to put it. Below everything else, below show toast, I'm going to put this new, kind of function. It's grayed out right now because we're not using it. But let's show you, if I take this away, right, this null coalescing operator, writer.write doesn't really like this too much, okay? And it'll complain when we start doing it. It'll go, hey, I don't know what you're doing here. That's bad. And we should definitely use this. Notice it says AGL is not null here, right, as an example. We don't know if it is now, but I recommend it's going to do something like this. So what it does is it does other things too that for us, if we don't use this null coalescing operator, or if we do use it, we don't have to worry about, checking it to see if it's null. Okay. So that's interesting. So now that we have this null coalescing operator, that makes me think about this, right? Makes me think about this. When I read from readline, could I use the null coalescing operator here as well, right? And instead of doing this check right here, right? Because this check right here is something else that I could do. So one thing that we could do instead of doing this thing that we're doing is we could do something that looks like the same thing. We can say, well, if that's null, right, then what if it's null? If it's null, we can put something like this in there. And then what that does is it actually removes, I'm going to do this, I'm going to accept the change that it's suggesting. I can do something like this, and then this idea cancels this whole thing here. I don't have to do it anymore, right? I can compact it into something that looks like this. So it's not in your PowerPoint, but I'm going to do it anyway because it's more efficient. I'm just going to take away that and reduce this using the null coalescing operator, because I don't have to do that if else, thing that I'm doing. It's just right here, right? It's all in one line. It's pretty cool. So I've done that now in my load character, and it's made my code a little bit more compact, right? So again, all I'm doing is I'm basically saying, hey, check to see if it's null, and I'm putting it in here. Well, if I can do this, then I really don't need to do any of these either, right? Because I don't even need to do this. I can go directly into settings if I want to, right? So that's something that else I can do as well. So I'm just going to undo those things, but I want to show you that that is definitely an option to do. So this is where, we're going to leave it because I wanted to kind of show you what format exception is. But realistically, we can use the null coalescing operator, and that would take care of pretty much all of this. Because we wouldn't need this anymore. We wouldn't need the character data at all. We would just go and put it directly. We could read line directly into settings because that's all we would need to do. All right, so that is this. I'm just showing you what this does here, and save character binaries. Let's put this up on GitHub because now we've added in a new function. So I'm going to say that it's PowerShell git add dot git commits -m, and we'll say added save character binary method. So this is a different method than the the save method that we have already. Here's the save character method. It just does this, right, with stream writer, right? And now we have an alternate method, which is save character binary. We're going to make it so it's a binary save of a character. I could have also said save binary character. That's also something that I could have named this this function, but it's fine the way it is. We could also add in one thing that we're missing here in our project is more comments. And I've talked about this as method level comments that we can add in. We haven't really done it a lot just due to time. I'm going to do that right now. So for example, my confirm exit, we can always do // and we can say this method prompts the user to confirm exiting the application. We can do that very, very quickly. I can do // and I can say this method, right, saves the character data to save the character data as text, that's what that is, to a specified file path. That's what this does, this save character. And then we can also do the same thing here, right? This method loads character data from a specified, loads character data as text, that's what we do, from a specified file path. That's what this does, right? That's the path. And as we go down, show toast is interesting, right? Because that's our own thing. This method, right, shows a toast notification with a specified message and type. Nice. Again, I'm getting this right from, Visual Studio. And I can say this method saves the character data in binary format to a specified file path. So this is what this does. So again, I'm just specifying for us when we look at this 5 years from now, if we do, right, what this thing does. And if I say hover over, it just tells me all that information too. So let's not forget to put our comments as we go. Okay, very nice. So now that we've talked about binary writer and we've talked about the null coalescing operator, let's talk about binary reader a little bit. Binary reader is the companion to binary writer, right? it has to read everything in the exact same order as it was written, or otherwise it won't work, right? So that's something to note. And what it does is it reconstructs each of the value by reading raw bytes from a file. That's what it does, and converts them into the same type that they've been written, from. So one thing that we have to say is binary reader and binary writer don't care about the type that you're writing. It doesn't really care about that at all, right? It'll write whatever you've given it to write. That's something to note, right? And it'll convert things, basic types. That's one thing it'll do very, very nicely, right? And it does have a few things, but we have to tell it what type that we're going to read. So this is kind of something interesting. Notice that it says read int32, read string, and read boolean. We have to tell it the type because it doesn't know the type that you're storing. It doesn't understand. All it sees is a series of bytes, raw data that's there. The reason why we need to tell it what to read is because each of these types, int32, which is an integer, string, and boolean, has a size. So that's how many bytes it's going to read in a row, right? Because it's representative of the data. When we're writing, it doesn't care. It's going to spit out the number of bytes it needs in the file, right? Because it knows how big the data is. But when it's reading, it doesn't understand that. It has to say, okay, well, I'm reading a bunch of raw data. What am I reading here? It doesn't know. Binary reader is agnostic. It has no idea what's there. It just sees data. It just sees like zeros and ones equivalent, right? And what we need to do is basically tell it what those things mean. We have to say, well, read the first four, pieces of 4 bytes here as an example, or 8 bytes, because these bytes represent an integer or a float or whatever, okay? Here, because we know that there are strings, we're reading strings, okay? And one thing to note when we do this, I want to do this binary reader, but the load file is a lot bigger, right? Because than what it is before. So I'm going to give you this whole thing again. It's massive. I don't know if I can actually. It's so big, because it's really huge. But it is in your PowerPoint. I'm going to see if I can copy. No, it doesn't allow me to do it. So it won't allow me to give it all to you at all in here because it's just too big. But this is what I'm going to do. So I'm going to take this file. You can get it from the PowerPoint online on Blackboard, okay? And so what I'm going to do is I'm going to grab all this, and I'm going to copy it. It's big. Well, I'll talk about it. I mean, again, I can reconstruct a lot of it from what we already have because really it's just a copy of the loader that we already have, the load character. I'm just modifying it for, that's all I've done. I modify it to read binary, right? So here's the first part of it. It's going to give me an error. I'm going to grab the next part of it right here, and I'm going to put it right under here. There it is. And then hopefully we'll have that whole piece of data right here. So this is the load character binary. And again, I'm going to put a little comment at the top, like this method, right, loads character data in binary format from a specified file path. This is good. And let's take a look at what it's doing. So again, we do the same thing. We use the file stream to create, to open up the file. We need to use the character data to read again. So here, again, if we're looking at this, we've done it this way, but remember we talked about we can actually use the null coalescing operator instead, right? And we might do that next week. Maybe we'll format it into a better way of doing things instead of using this. But this week I want to show you that we can use binary, the character data as a struct, right? So the same thing. So here's read string, but what if I wanted to use something else? What if I said, I'm just going to show you this. If I said reader dot, what can it do? So if I said read, what things can it read? So it can read a bunch of things, right? It can say, I can read a 7-bit encoded integer. I can read a Boolean, a byte, bytes, multiple bytes, a byte array, basically a character array, decimal, double, half. So half is like a, kind of like a float. That's what that is. An integer 16, an integer 32, an S byte, right? And so on. Okay, these are all the things. Huh? All these things, that we have here, that are things that we can do with our data. This is all the stuff that we can do. So there is a read though. right? So what read allows us to do is it allows us to read data, and it kind of, we have to interpret what that means. It'd be nice if we had something like this. If I said something like, well, I want to do character data, right? So if I was going to save my struct, it'd be nice if we can do this, right? Read, from our thing, we know that it's struct data. The size of this is going to be something like this. Unfortunately, the binary reader does not do that, right? It doesn't allow us to do this. Now we could construct something called an extension method to do this, but for now, it doesn't allow us to do reading our personal struct. That's a negative, right? Because that means we have to deconstruct our structure, save it as whatever we have to do, and then read it back into our structure to reconstruct it and package it back together. So that's one disadvantage of using structs when it comes to this, even though we made our custom data type. Or, by the way, classes next week, same thing. If I want to write in binary, I got to construct it. I got to deconstruct our class or struct, and then reconstruct it, pull it back together, and make it again, right? Because there is no binary reader that does the same thing. So this is something to note. So this is our file. This is our load now. And what this does is it loads binary data. So now it reads it, all this stuff, in the same order that we wrote it. Okay, that's something that we did. So let's put this up on GitHub as well. So save, and we're just going to go to PowerShell, git commit -m, and we'll say added load character binary method to program.cs. There we go. Okay. So those are the few things we've done. We haven't tested those yet, but we've actually, kind of have made those things. And we've made them these things because we want to be able to both read and write, in binary. And that's one of the things, the outputs of today's class, we're going to do that. And that's what we're doing. Okay, so there you go. So you can see that this is what we've done here. And we've kind of talked for about an hour. And before we get into what JSON data is, because I want to talk about that as well. This, again, I'm just hammering at your in-class exercise 11 with you, just getting through it. And that's what I've been showing you. Let's take about 10 minutes, right? I have this one thing to do. And as soon as I'm done, I'll come back and we'll restart this and we'll continue with storing data and reading stuff with JSON, okay? I'll stop now and we'll come back in about 10 minutes. So give a chance to get your coffee, warm up a little, those kind of things on this cold day.